Honors Algebra 2, Chapter 8, Section 4. So tonight we're going to look at simplifying rational expressions and then multiplying and dividing rational expressions. So first thing is just kind of review from previous math how to simplify. So when we're looking at simplifying these expressions, we're looking at when it's all multiplication. Once it's all multiplication, then you can look for things that are in the numerator and denominator that you can reduce. And so we might need to rearrange this so you have the like bases, but you can see how these two m values here reduce with two of these m values. These two h's reduce with two of these h's, so only have one h left over in the denominator. This x reduces with one of these x's, so I have x squared. And then the numbers, this 2 goes into 24 12 times, and then I can divide both the 12 and 18 by 6. So 12 divided by 6 is 2, 18 divided by 6 is 3, and then whatever's left over I can multiply on the top. So this is 2x squared m to the 4th all over 3h. And so if you need to do that in smaller chunks, you can. That's kind of what we're doing. We're reducing is really all we're doing in that first problem. Factoring. So when we're factoring quadratics here, first thing you should always look for is a GCF. And so that these all are divisible by 3. So you have to factor out a 3. And I'm left with x squared plus 14x plus 13. And then I can look at, can I factor that again? And I can. Factors to x plus 13 and x plus 1. For number 3 here, we can look for a GCF, but there's not one. So now when I factor this, I have to have a 2m and m. And then these two numbers are going to multiply to be negative 24. So I'm looking at like a 1 and 24, 2 and 12, 3 and 8, 4 and 6 of the different combinations. Now, the signs have to be opposite, and that's huge to know that. See this negative here when you multiply these two terms? So these multiply to become a negative 24. So these are going to be opposite. And so when I'm looking at my OI value to make my middle, those are going to be opposites as well to get this 13. So I'm thinking about how I can multiply like a bigger value here, like 6. 6 times 2 would be 12, and I have 4. That doesn't work. I'm doing minus here and plus here. If I do 8 times 2 is 16, and then do a negative 3 there, then I have my OI value that's 16 minus 3, which is 13. And so that would factor. So there's some logic involved in factoring that. In 4, it's a special case. It's 4y minus 3 and 4y plus 3. And then for 5, it's similar to question 3. We have to kind of break it up. These are prime numbers, though, which kind of help us out. We have 5d and d. The only way to get that, the only way to get these two numbers is going to be 3 and 1. So 3 and 1, now they can both be negative, both be positive. You have to be negative to have a middle negative value. Let's check our OI value. That's negative 15 and negative 1, which is negative 16. So that factors properly. When these are prime numbers, it's a little easier than I got 24, which has it's a composite, has a lot of factors. So we're going to be doing the same thing in today's lesson. And really, we're just going to be factoring the numerator and denominator and then looking for reducing. And so on the top, if I factor out a 3, I have x minus 2. On the denominator, I factor out a 4, and I get x minus 2. Now we're multiplying. The numerator and denominator both are multiplying here. We can reduce this entire quantity. X minus 2 over x minus 2 is 1. So then our final answer here would be 3/4. So that'll be simplified. So even though we have our variables here, we can reduce it down to 3/4. The second problem, we need to factor it. Now these x's do not reduce. You cannot reduce the x's right away because there's like a parenthesis in the numerator and the denominator. Whenever you have addition subtraction, it ties those terms together, so it's a quantity. And so we first need to factor to change it into multiplication. So the bottom one factors to x minus 1 times x plus 1, and that's the key. Because now we have a multiplication. So now I have x minus 1 and x minus 1, the entire quantity reduces. So we get 1 over x plus 1. And then the one down here, a little bit more factoring, a little more difficult. At the top is still a special case, 2a minus b and 2a plus b. and the denominator factors 2, and we can use the numerators to help me factor it. I'm thinking 2a and 2a, and it's going to be a negative b and a negative b to get a positive b squared here and a negative 4ab. We can check our OI. Negative 2ab and a negative 2ab is negative 4ab, so that works. So does anything reduce? Yep, this and this, those two quantities reduce out. So my final answer would be 2a plus b all over 2a minus b. And so that's simplifying. You know, a factor to get to multiplication, and then you can reduce the entire quantity. So a few more here. This one, I need a factor at the top. When we factor the bottom is not in standard form, so I might actually like rearrange this a little bit and then try factoring it. A little more difficult to factor because we have a negative a value. If you wanted to factor a negative out of that entire thing, so you have like 2x squared plus 3x minus 20, you might want to do that. I prefer that when I'm factoring that. And so if I factor that, it's going to be 2x, x, and then I get negative 20 over here to get a 3, I'm thinking 5 and 4, so here, bigger positives. So that works. Now I had this negative out in front here still, don't lose that. So now we're still multiplying. I can reduce out the 2x minus 5 and 2x minus 5. On the top I have x plus 3, on the bottom I have that negative. Distributed through the x minus 4, I get negative x minus 4. So that would be the final answer. Let's do the bottom one here. So in this one, I can rewrite y minus 5, the quantity squared, just as there's 2 of them. If you want to write it out, you can. You don't have to. On the bottom, though, we can factor that to 5 minus y and 5 plus y. And we can look at, do any of these reduce out? Is y minus 5 the same as 5 minus y? No, but I can rewrite that bottom quantity by factoring out a negative. If I factor a negative out of that, I get a negative 5 plus y. Just that first quantity. Now those will reduce out. And I get y minus 5 in the numerator. And the denominator is a negative 5 minus y. Can't reduce anything out there. That stays. So let's have this be your video problem for the night, is to simplify that problem. The other concept you need to look at tonight is to multiply and divide rational equations. So it's pretty much doing the same thing we're doing, but we're adding more expressions. So we have to multiply here. And when we're multiplying fractions, we should recall that we need to first reduce when possible. So here I can think how a 5 in the denominator, a 10 in the numerator, so I can reduce those to 2. 7 reduces it to 14, you get 2. It's going to have reduced values, which makes our multiplication much easier. The same thing occurs with the variables. On the bottom, this n and this n squared, that's n to the third, so that reduces out with that n to the third. So then on the top, I have 2n to the fifth in the numerator. In the denominator, I just have 2. But look at that, our 2's reduced again. So double check that, so you get n to the fifth is the final answer reduced. So for this one here, we want to, we realize we have 2 fractions. We need to factor first in the denominator here to see what the denominator is made of. So we have 2x and x. And then we're going to have 3 and 1. And we want more negatives than positives. So we have negative 3x and 2x are always to the right middle term. And so now I'm looking for things in the numerator and denominator that reduce. And so I see a 2x minus 3 here, and an x minus 3, one of these reduce. And I have an x plus 1 here, it doesn't reduce with anything. And so my numerator is 2x plus 1 all to the fifth times 2x minus 3 squared all over x plus 1. And at this point, we don't need to worry about actually distributing it out. That's too much mess.
Hi, my name is Lucy, Daddy's Dada, and I'm gonna say 1 plus 1 equals 2, 6, and 3 plus 3 equals 6, 5 plus 5 equals 10. And 5 times 20 equals something, but I don't know. And 1 plus 1 equals 2. 4 plus 4 equals 8. 5 plus 5 equals 10. 3 plus 3 equals 6.
So last two problems here we have to divide. And dividing fractions, we first need to change the multiplication. While we change the multiplication, we're also trying to factor some of these. So this first fraction, we're just going to factor out of 5x. And we're left with x minus 4. The bottom one stays x plus 5, can't factor anything out of that. And we're going to change the multiplication. And then this was over 1, so then it's reciprocal 1 over x minus 4. Now everything's multiplication. As we look for reducing, we see how we have a common factor, x minus 4, those reduce out. So on the top we end up have 5x all over x plus 5. Last one, so again we're dividing, so we first want to rewrite as multiplication. As I do that, I'm going to factor. So this first one becomes x minus 1, actually x plus 1, and then x minus 2. And the bottom I factor 3 out, and you have x minus 1. And then multiplication, and then 3 over, now x squared minus 1, we need to try factoring that, x minus 1 and x plus 1. So then we can look for reducing. See the 3's reduce, don't forget about those numbers. We have x plus 1 reduce. So then we get, on the top we have x minus 2. At the bottom we have x minus 1, the quantity squared.
Yes.
Can I wear my hat?
Mommy did not get her.
Mommy did not what?
Want to get her hat. I want to get her hat.
Thanks, sweetie. And that's the last problem for dividing rational functions. So you should be able to simplify them by factoring and reducing. You actually have to multiply and divide them, and as you do that, to continue simplifying them. So call it good for the night. We'll see you tomorrow.